Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, D. Viraj Institute of Technology, Narsapur. In this linear algebra and calculus course, today we are going to see third example on maxima and minima without constraints. Let us take the problem statement. Examine the maximum and minimum values of f of x comma y is equal to sin x plus sin y plus sin of x plus y. Now let us see the solution of this problem. So given function in terms of two independent variables as f of x comma y is equal to sin x plus sin y plus sin of x plus y. So for this we have to use the sufficient condition for a function to admit either maximum or minimum is first order partial derivative should be 0. We have to compute dou f by dou x is equal to 0. So whenever you are differentiating partially with respect to x, other variable will be treated as constant. Sin x derivative is given by cos x and the sin y derivative is 0 and sin of x plus y derivative is given by cos of x plus y, and inner function derivative with respect to x is given by 1 and inner function derivative is 1 equal to 0. Similarly, we have to compute dou f by dou y is equal to 0. This implies sin x derivative is forced to 0 and the sin y derivative is given by cos y and sin of x plus y derivative is cos of x plus y is equal to 0. So this you label as equation 2, this you label as equation 3 and given function as equation 1. So our objective is to find out the stationary points by solving equation 1, 2 and 3. So by solving 2 and 3, either we get the stationary point directly or sometimes we will get the relation in terms of x and y. By using that relation into one of these equations, we are going to get the stationary points. So we are going to follow the second approach. So let us try to simplify this. We subtract one from the other. So if you subtract equation 2 and 3, this you have minus sign, here we have minus sign. This cos of x plus y both are cancelled. We are going to have cos x minus cos y is equal to 0. It implies cos x is equal to cos y. On comparison, we are going to get the relation in terms of x and y as x equal to y. Now use that relation in one of the equation 2. We are going to get cos x plus cos of x plus x is given by 2x equal to 0. So here, in order to find the value of x, we have to use the formula cos c plus cos d is given by 2 cos c plus d by 2 and cos c minus d by 2. By using this relation, we are going to get 2 times cos of 3x by 2 and cos of x minus 2x is minus x, cos of minus x by 2, and cos is even function, cos of minus theta is cos theta. Therefore, cos of minus x by 2 can be written as cos of x by 2 and it is equal to 0. So from this we are going to have cos 3x by 2 is equal to 0 or cos of x by 2 is equal to 0. So cos is 0 only when theta is plus or minus pi by 2. Then we are going to have theta 3x by 2 is equal to plus or minus pi by 2, and from this also you are going to have x by 2 is equal to plus or minus pi by 2. So from this, if you observe left hand on LHS and RHS, 2 and 2 are cancelled. We are going to have x is equal to plus or minus pi by 3, and from this we are going to have x is equal to plus or minus pi. When x is plus or minus pi by 3, from the relation x equal to y, we are going to have y is also plus or minus pi by 3, or x is from this we are going to have y is also plus or minus pi. So from these two, The stationary points are, therefore the stationary points are plus or minus pi by 3, comma plus or minus pi by 3. Another one plus or minus pi, comma plus or minus pi. So in total we have here 4 stationary points. At each and every stationary point we have to check the sign of Ln minus n square. So first let us compute the definition of L. L is given by dou square f by dou x square. So take the dou by dou x of dou f by dou x, which is given by cos x plus cos of x plus y. So with respect to x, whenever you are differentiating, cos x derivative is minus sin x, and cos of x plus y derivative is given by minus sin of x plus y, and n definition is given by dou square f by dou y square. It is equal to dou by dou y of dou f by dou y. It is cos y plus cos of x plus y. And we have to compute the partial derivative of this with respect to y. Cos y derivative is given by minus sin y, and cos of x plus y derivative is sin of x plus y. And finally we have to compute m, dou square f by dou x dou y. It is nothing but equivalently dou by dou x of dou f by dou y. It is nothing but dou by dou x of, this is second derivative we have to take, cos y plus cos of x plus y. So upon differentiating, we are going to get cos y is treated as constant as it is independent of x. We should take cos of x plus y. Its derivative with respect to x is given by minus sin of x plus y. Here inner function is given by x plus y. X plus y derivative with respect to x is given by 1. So we got the expressions for L, n and m. So at each and every stationary point, we have to check the sign of Ln minus n square in order to ensure whether it is possess maximum or minimum. So first let us take the first stationary point at pi by 3 comma pi by 3. Let us compute the value of L. So at pi by 3 comma pi by 3, minus sin pi by 3 minus sin of pi by 3 plus pi by 3. So it is given by minus sin pi by 3 is given by minus root 3 by 2, and sin pi by 3 plus pi by 3 will be sin 2 pi by 3. So 2 pi by 3 can be written as 2 pi by 3 can be written as pi minus pi by 3. Pi minus theta comes in second quadrant where sin and cosecant are positive. So sin 2 pi by 3 can be written as sin of pi minus pi by 3 and can be equal to sin pi by 3. So again sin pi by 3 is given by root 3 by 2. So minus root 3 by 2 minus root 3 by 2 will gives you minus root 3. With the same argument, we are going to get n as minus sin pi by 3 and minus sin 2 pi by 3, and 2 pi by 3 can be written as pi minus pi by 3, and sin pi minus theta is given by sin theta. Therefore sin pi by 3 you will get here. So from this you are going to get minus root 3 by 2 minus root 3 by 2, in total minus root 3. Similarly, we have to compute m value. M is given by minus sin of pi by 3 plus pi by 3. This is minus sin 2 pi by 3, and this is given by minus root 3 by 2. After computing all L and M values at stationary point, now we have to check at pi by 3 comma pi by 3, Ln minus m square is equal to minus root 3 times minus root 3 minus minus of root 3 by 2 whole square, and this is given by 3 minus 3 by 4. It is 9 by 4 and it is greater than 0. And we also know that L is given by minus root 3, it is less than 0. So from the working rule we can conclude that at pi by 3 comma pi by 3, f of x comma y has maximum, and f max at the stationary point pi by 3 comma pi by 3 is obtained by substituting the stationary point into the function. Our function is given by sin x nothing but sin pi by 3 and sin y nothing but sin of pi by 3 and sin of x plus y nothing but sin of 2 pi by 3. So sin pi by 3 is root 3 by 2 plus sin pi by 3 is given by root 3 by 2. Sin 2 pi by 3 again with the same argument it is sin pi by 3 and it is also given by root 3 by 2. Then simplification will gives you 3 times root 3 pi by 2. This is what f max value at pi by 3 comma pi by 3. Similarly, we have to check the sign of ln minus n square at another stationary point. And another stationary point is given by minus pi by 3 comma minus pi by 3. And L sign is given by minus sign of minus pi by 3 minus sign of minus pi by 3 and minus pi by 3. So L is given by here minus sin x minus sin of x plus y. We are using these right hand side expressions for L, N, M to compute sin of Ln minus n square. So sin of minus theta is given by minus sin theta, minus into minus plus. We are going to have sin of pi by 3 and plus the same argument you are going to have sin of 2 pi by 3 plus sin of 2 pi by 3. So from this you are going to have root 3 by 2 plus root 3 by 2. In total it is root 3. And n is given by minus sin of minus pi by 3 and minus sin of minus pi by 3 minus pi by 3. With the same argument you are going to get n value also root 3 by 2 plus root 3 by 2 is equal to root 3. So after computing L and M, next M value minus sin of minus pi by 3 and minus pi by 3. In total sin of minus sin 2 pi by 3. This is given by sin 2 pi by 3 and it is also equal to root 3 by 2. Now let us check this ln minus n square sin. It is given by root 3 times root 3 minus root 3 by 2 whole square. With the same argument you are going to have 9 by 4 it is greater than 0. But L is given by root 3 it is greater than 0. So from the working rule we can conclude that f of x comma y has minimum at the stationary point minus pi by 3 comma minus pi by 3, right? And function f min value at minus pi by 3 comma minus pi by 3 is equal to we are going to have sin x plus sin y plus sin of x plus y. Sin minus pi by 3 is minus root 3 by 2 and minus root 3 by 2 and minus root 3 by 2. It is minus 3 root 3 by 2. This is what your f min value. So we computed the maxima and minima for the two stationary points pi by 3 comma pi by 3 and minus pi by 3 comma minus pi by 3. And similarly we have to compute the sin of ln minus m square at another two stationary points which are plus or minus pi comma plus or minus pi. And L is given by what here? Sin x plus sin of x plus y. So we know that sin of any pi is 0. Whenever we substitute x equal to pi here, sin pi is forced to 0 and sin of pi plus pi 2 pi also forced to 0. Therefore we will have L is equal to 0. With the same argument n is also sin of plus or minus pi plus sin of plus or minus pi plus or minus pi. In total we will take sin 2 pi or sin of minus 2 pi. In both the cases these terms forced to 0. Then n is also 0. And m is given by sin of plus or minus pi and plus or minus pi, and again it will be forced to 0, right? So generally for plus we have to compute the sin of ln minus n square at two different stationary points pi comma pi and minus pi comma minus pi. But it is clear from the context that sine of any pi is 0. That is why I am writing plus or minus pi at a time. But we are not supposed to do that in the examinations. We have to write pi comma pi separately and minus pi comma minus pi separately. So therefore, we are going to have the sign ln minus m square as 0 into 0 minus 0 square is equal to 0. Therefore, from the working rule, we can conclude that f of x comma y has the conclusion that, from the working rule, we can say that no conclusion can be drawn about maxima and minima and needs further investigation. This is taken from the working rule. So this is the example for function without constraints. Thank you for watching the video. In the next class, we will see maxima and minima with constraints. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.